Hello and welcome to a little extension called graphing absolute value equations. So yesterday we solved absolute value equations. Today we're going to graph them. Here are the solutions to solving absolute value equations. Make sure you're paying attention to those problems that have no solution. For example, number 24 is one of them. Number 30 is one of them. And then 43 and 44 and 42. Those 42, 43, 44, those were all those absolute deviations. So again, they're not difficult questions, but I'd mark them as challenge. So if you want to give those a try, definitely go for it. All right, so here's our lesson for today, graphing absolute value equations. It's a nice little offshoot as to kind of relate to what we worked yesterday and applying it to something new. So this is the parent function. Let's see if I can, there we go. All right, so this is the parent, this is the most basic absolute value equation that we have. What we're gonna do is we're gonna plug in numbers for x and y. I'm gonna use -3, -2, -1, 0, 1, 2, and 3. Plug in 0, absolute value of 0 is 0. Plug in 1, absolute value of 1 is 1, 2, and 3. Now when we do our negatives, -1, absolute value of -1 is +1. Absolute value of -2 is +2. Absolute value of -3 is +3. And then what we're going to do is we're going to graph these, and we're going to see a new shape. 1, 1, 2, 2, 3, 3. And you might think, oh, it's just a line. No, it's not a line. Now the reason why it's not a line is because when we graph the negative values, you're going to see something interesting happen. Let's try that again. All right, -1, 1, -2, 2, -3, 3. It actually creates a V shape. So that is a new type of function for you guys. You guys have not seen this yet. But because the distance is never negative, you're going to notice there's no negative values in this problem. Now, could we make it so that there's some negative values? Yes, we could. I'm going to change this to a -2, the absolute value of x minus 2, to show you that it is possible for there to be negative y values. All right, let's use our same values here, -3, -2, -1, 0, 1, 2, and 3. All right, when I plug in 0, you get 0 minus 2 is -2. There's a negative value. Plug in 1, 1 minus 2 is -1. Plug in 2, absolute value of 2 is 2, minus 2 is 0, and 3 gives us 1. Now, when we do -1, absolute value of -1 is +1. +1 minus 2 is -1. Absolute value of -2 is +2. Minus 2 is 0. Absolute value of -3 is 3. Minus 2 is 1. And then you're just going to plot these points. 0, -2. 1, -1. 2, 0. 3, 1. -1, -1. -2, 0. And -3, 1. Again, it makes a V shape. And this one does have some negative values, but the reason that it does have those negative values is because of this -2. It takes the entire graph and it shifts it. So that was the original parent function, and it basically takes that graph and it shifts it down 2 units because that -2 is there. And we're going to talk about the transformation. It's called a transformation. We're going to talk about that tomorrow in class. Now this is a unique one. This one you have to be careful. And I will explain why. Do you notice how these were symmetrical here? Symmetry. Take a look at this. Right there, these values here are symmetrical. -2, the -1s line up, the 0s line up, the 1s line up. Same thing here. The 1s line up, the 2s line up, the 3s line up. Now, if I do that on this problem here, it won't work. And what I want to do is I want to choose -2 as the middle value, and then go -1, 0, 1, -3, -4, -5. The reason why, find the value that makes the absolute value part of the equation equal to 0, which is -2. that will solve all of your questions in terms of it being symmetrical. If you don't do this, you're going to have problems. So I'm going to choose negative 2 plus 2 is 0, absolute value of 0 is 0. Negative 1 plus 2 is 1, absolute value of 1 is 1. 0 plus 2 is 2, absolute value of 2 is 2. And 1 plus 2 is 3, absolute value of 3 is 3. And then go negatives. Negative 3 plus 2 is negative 1, gives us 1. Negative 4 plus 2 is negative 2, which gives us 2. Negative 5 plus 2 is negative 3, which gives us absolute value of negative 3 is 3. And as you can see now, it is symmetrical. So, if you want to make your graph symmetrical, this is what you do. Negative 2, 0. Negative 3, 1. Negative 4, 2. Negative 5, 3. And then negative 1, 1. 0, 2. And 1, 3. As you can see, we still have the b, and it is shifted to the left 2 units. This is another type of a transformation, and I'm going to explain these transformations tomorrow. Basically, it's the same graph, but it's to the left 2, which is odd because it's a plus 2. But we'll talk about that in class. Alright, 2 times the absolute value of x. This one here, the value that makes this 0 would be 0, so you can put 0 in the middle of your table. Alright, now we're just going to be taking all of our values and doubling them because we're multiplying by 2. 0 times 2 is still 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. Absolute value of negative 1, if I go to negative 1, is 1 times 2 is 2. Absolute value of negative 2 is 2 times 2 is 4, and that gives us 6. Okay, very similar graph here, except for what you're going to notice, it is much steeper or skinnier, whatever you want to call it. It's called the vertical stretch. And again, that vocab term, vertical stretch, I will explain that tomorrow in class. Alright, so there's your graph. And I got one more sample problem for you guys, negative 1/2 x. Again, the value that makes this 0 is 0. And I'm actually going to choose 2, 4, and 6. And negative 2, negative 4, and negative 6. Now the reason why is because I'm multiplying by a half. So if I multiply odd numbers times a half, it's just going to give me decimals. This will make it so I have nice whole numbers. Alright, 0 times negative 1/2 is 0. 2 times negative 1/2 is negative 1. 4 times negative 1/2 is negative 2. And 6 times negative 1/2 is negative 3. Plug in negative 2. Absolute value of negative 2 is positive 2 times negative 1/2 is negative 1. And our trend continues. Negative 1/2 times 4 is negative 2. And negative 1/2 times 6 is negative 3. Now this one is really cool because you're going to notice that it does 2 things. This one goes down. It's a reflection over the x-axis, and it is much wider than our other graphs that we've dealt with so far. And this is called a vertical shrink. And again, another vocab word. I'm going to talk about what a vertical shrink is tomorrow. For the time being, you just want to know how to graph these, and we'll talk about all of the vocab tomorrow. So here's what you guys are going to be working on in class. Thank you guys for tuning into a great extension.